Now we're going to take a look at cardioids. So while this is from the book, while translating from polar coordinates to Cartesian coordinates, it may seem simpler in some instances. Graphing the classic curves is actually less complicated in the polar system. The next curve is called the cardioid, as it resembles a heart. This shape is often included with a family of curves called lemnicons. And that's a funny little thing with a C. It's not quite a C, but whatever. But here we will discuss the cardioid on its own. Formulas for cardioids. The formulas that produce the graphs of the cardioids are given by r equals a plus or minus b cosine theta and r equals a plus or minus b sine theta, where a is positive and b is positive, and a over b is equal to 1. The cardioid graph passes through the pole, as we can see in these examples on here. So here's an example of r equals a plus b cosine theta. Like that. R equals a minus b cosine theta, so it goes the other direction. R equals a plus b sine theta goes up, and r equals a minus b sine theta. So how to sketch the graph of a cardioid? Check the equation for the types of symmetry, the 3 types of symmetry. Find the zeros, set r equal to 0. Find the maximum value of the equation according to the maximum value of the trigonometric expression. Make a table of values for r and theta and plot the points and sketch the graph. So I usually just do the last 2 steps of this, but here we go. Let's look at r equals 2 plus 2 cosine theta. So if I go back up to here, it's probably going to be something resembling this because of that format, and it's a plus. So I'm thinking about this, 2 plus 2. So the most this will become is r is going to be is 2 plus, and the biggest cosine is going to be is 1. So 2 times 1 is 2. 2 plus 2 is 4. So it's probably going to be 4 on this direction. Okay, so let's go ahead and plot some points. We'll go with our standard thetas, and then I'm going to do cosine theta. I'll do 2 cosine theta, and then I'll do r equals 2 plus 2 cosine theta. So do 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 3 pi, no, I'm not doing the pi over 4s, 2 pi over 3, 5 pi over 6, pi, and again I do 7 pi over 6 just to check. So I'm doing these. 0 is going to be 1, pi over 6 is square root of 3 over 2, pi over 3 is 1/2, pi over 2 is 0, and we're negative 1/2 for 2 pi over 3, negative square root of 3 over 2 for 5 pi over 6, negative 1 for pi, and then 7 pi over 6 would be, cosine of that would be negative square root of 3 over 2. So 2 times each of these will give us 2, square root of 3, 1, 0, negative 1, negative square root of 3, negative 2, negative square root of 3. And then I'm going to do 2 plus each of these, so it's going to be 4. I'm going to do the decimal approximations now. So this will be approximately let's see here. It's 1.73, so it'd be 3.73 roughly. It's 3, that's 2, that's 1, and then 2 minus that would be, what's that going to be? Approximately 0.27, and then we're at 0. And then for the negative 3, we're going to be back to here, so around 0.27. So I think what's going to happen here is that we have some symmetry going on. So let's just start with this and see what happens. We have 0 is at 4, so this is 1, 2, 3, 4. Pi over 6 is at 3.73, so right about there. Maybe a little further up there. Pi over 6 is at 3. Pi over 2 is at 2. 2 pi over 3 is at 1. And then 5 pi over 6 is going to be here at around 0.27, so down there, and then we're at 0. Oh, then we're back at 0.27. So this does have some kind of symmetry. So let me just test the symmetry. What do we have? If I put in negative theta, r equals 2 plus 2 cosine of negative theta. Isn't that going to be the same thing as r equals 2 plus 2 cosine of theta? So, because cosine of negative theta is the same as cosine theta. So it's going to be symmetric with respect to this axis. So these points will just be reflected. So out to here. This will be out to here. And then this will be out to here. And then out to there. So we get this kind of a shape. Like that. And there's our curve. It's kind of fun. Okay. Now you can always plot more points. You can go all the way to 2 pi with that. Okay, we'll stop with that.